Okay, hopefully we can get close to the end this time. This is the hiker's displacement, and we're asked to find the magnitude of the hiker's displacement. To find the magnitude of a vector, we square each of the components and add them. And then we take the square root of the whole thing, which in this case is 1.16 kilometers. And I did need a calculator for that, and that's answer B. So 1 mark for that if your paper is correct. Question 7. The delta in delta R, the displacement, means a change in. So that's answer B. 1 point for that. Question 8 asks us, what angle does the vector V 340 meters per second make with the z-axis? Well, if we draw a right-handed axis set, so that's x, and that's y, and z going up the page, so x, y, and z up the page, so y is going into the plane of the blackboard there, then this vector has an x component of 3 and a y component of 4, so something like this, 1, 2, 3, and 1, 2, 3, 4. So it goes into the board like that, okay? But it doesn't go up the z-axis at all. The z-axis is 0, so there is 90 degrees between that vector and the z-axis. So that means the answer is E to question 8. 1 point for that. What angle does this vector make with the y-axis? Well, I'm just going to draw the y-x plane there. So now the z-axis is coming out of the board, and the x component is 1, 2, 3, and the y component is 1, 2, 3, 4. So here's the vector, and we want to know what angle it makes with the y-axis. So this angle, we'll call it theta, has a tangent equal to the opposite side, that's the x component, 3, over the adjacent side, that's the y component. So a tangent of 3/4, which makes it 36.9 degrees, answer B. And finally, these notations on question 9. Vx x hat, that's the x directional, plus Vy y hat. Well, this is a vector and this is a vector with the arrow over the top, so this is a vector product. If we're trying to write something as components, this is just a scalar. It's a plus or a minus number with a magnitude, but it hasn't got any sense of direction because this bit does the direction. Right? The directional does the direction. So that's the correct way of writing that vector in components. There should be no arrow over these, so A is wrong. B. Again, we've got a vector here times by a scalar, cos theta, whatever that is a scalar quantity, times by another vector. So we've got vector times vector plus another of the same. Well, if we're trying to write something as components, then we need a scalar multiplied by the directional. Remember, this bit says along the x-axis. So altogether, that's a vector. So that would be the correct way to write the first part of B, and the correct way to write the second part would be V sine theta y hat. So B is also wrong. C, we have just this plus this. This is a vector in the direction of V, and this is a scalar number, so this is a short version of V, less than 1, cos theta is always less than 1. This is the same thing, less than 1. So this is another short version of less than V. So this actually is a vector pointed in the direction of V. And it's this fraction of V plus another fraction of V. And the two together just make another vector pointing in the direction of V. So this is also wrong for writing down components. So answer D is correct. None of those are correct vector notations for writing out the components. And now, I wish you adieu. Have a good Thursday. And on Friday, Professor Takarik will join you.